For those unfamiliar with working with data, this will introduce you to the things to look for. As mentioned in the overview video, data can really be anything from text to images to lab specimens. Datasets structure these variables based on some parameters. You may be used to searching for books and articles, finding statistics mentioned and restating those. These are not data, but they come from data somewhere, hopefully. You may also find tables in an article that summarize findings, like this table of statistical test results. Although it is in a table, it is not a data set. Again, they came from raw data somewhere. When searching for data, it is best to search in data repositories like Harvard Dataverse and ICPSR, or in data aggregators such as data organizations and oversight bodies' websites like the National Center for Health Statistics, FDA, or Department of Transportation. You can also search the web for general topics. There is a book that is all data sources listed in the readings called The Reference Guide to Data Sources by Bowder. It provides places to go based on topic. Also, be sure you understand what exactly are the numbers and categories being presented in the tables you find. That, and searching on data sites instead of in articles, will help you avoid things like summary tables, survey instrument validity and reliability results, and tables with instrument and statistical tests. So, what is a data set? To understand it, let's think about how data are arranged. The majority of data work is done quantitatively, that is, using measurable, quantifiable values. All of the images here show quantitative data. Qualitative research, such as focus groups and interviews, will be less of a focus for this course. However, the results of qualitative research help to inform quantitative analysis and conclusions made. Quantitative data are arranged in a set based on some set of rules. The structure most familiar to everyone is tabular data, where data are arranged in tables or columns. We often view these in a spreadsheet. Another type of tabular data structure are delimited data tables. CSV and TSV are the most common, and these files are not associated with any software since they are simple text files. They are ways of structuring the data. CSV means comma-separated values. Each column is indicated by a comma. A new row is indicated by 2 commas. TSV means tab-separated values. Just like CSV, they use a delimiter. Instead of a comma delimiter, they use the tab as the delimiter, aka the item that separates values. They can be opened in tons and tons of programs, including Excel. Here you can see the same data as CSV on the left and TSV on the right, open in Windows Notepad program. The first column name is athlete and lists athlete names down the column. The next column, age, shows the ages down that column, separated from the first column using a delimiter, either a comma or a tab. We recommend making use of these data files. There are some other common ones out there, such as SAV files, which are the file abbreviation for data saved in SPSS software for social sciences research. You can search online for a free converter, which will convert the save file to CSV. I will mention this as some folks have made use of shapefiles in the past. Shapefiles are not required nor often used for this course because most systems, such as Tableau, already have shapefiles as part of their internal data. A shapefile is exactly what it sounds like. It provides the outline or shape of a thing in the place it is located geospatially. For example, if you map data by state, the shapes and locations of the states are already present in Tableau, so it will create a map for you. However, if you want to map the boundaries of counties or cities within a state, these are not provided by Tableau, so you would need to get shapefiles from the Department of Transportation for the state of interest. Tableau will plot a dot at the center of cities, but the shapefile is not provided by default. Shapefiles cannot be opened by any default software. The shapes will be revealed once loaded into Tableau. Now that we've talked about the general structure, what are the components of a dataset? For the sake of our understanding, a dataset can have multiple data tables, documentation, and supplemental files. See this diagram from Dataverse Data Repository as a visual of how the data files and documentation are all part of the larger data set. So be sure to cite the data source, but you should also specify in your writing what years, files, tables, etc. you use and the navigation toward finding them. Each column has a data type. There are various ways to categorize them based on how different systems work. However, they generally fall into these 4 categories: nominal, ordinal, interval, and ratio. Nominal data are simple names and ID numbers. Ordinal data are categories like nominal, but they have a clear order, such as letter grades from A to F. Interval data takes it to the next level, where things have a clear order, but they are also evenly spaced. Each hour on a clock is 60 minutes apart, and temperature in Fahrenheit or Celsius is evenly spaced by degrees. However, there isn't really a real zero. 0 degrees does not mean the absence of temperature. Ratio data are real numbers, where 0 represents an absence of something. Decimals are truly meaningful decimals, and so on. If you happen upon other data types, such as double or float, these simply refer to the number of decimal places or other features that are saved. This helps either conserve storage space or provide for increased numeric specificity in calculations. Having learned this, what data type is the data type list of nominal, ordinal, interval, and ratio themselves? Pause here to think of your answer and then press play again to hear the answer. It's ordinal. They are categorical and they have a clear order from nominal to ratio, but they don't have any type of even spacing or a 0 value. As I mentioned earlier in this video, the results of qualitative research help to inform quantitative analysis and conclusions made. For example, if a business regularly has fewer customers at a certain time of day, and they interview people and find out that there's construction and major traffic on the nearby main road at that time, that can help them avoid making changes to their business that did not account for this outsized cause. As you look at your data set and conduct a literature review, think about how the findings of others' research will help inform the way you categorize and make groups, how you interpret changes, spikes, and trends, and how conclusive your findings are. We will take things step by step as a way of introducing many data topics here with the hopes you have enough knowledge, skills, and abilities to know what you know and know what you don't. We also hope that the process of working with data throughout this course will also help you be able to describe needs you have in the future when collaborating or learning more.